I'm just going to quickly show you how to get your orthogonal drawing in place and just go over some of the key things you need to remember when we're using the T-square, which we haven't used very much, and a drawing board. So these need to come from the Viscom room, and you need to make sure you're reading the information really quickly and carefully. One, remembering that all measurements come from the actual line on the ruler lining up, not the end of the set square. The set square measurement doesn't start right on the end, it starts a little bit in. So important things to check. The other thing that's important to check is that you always have your T-square with the numbers so you can read them. Otherwise, if it's the other way around, that's not right angles and your drawings will be all wrong. I also found using this drawing board from school that the tape, masking tape, comes off when I put it on the top there and I'm using the T-square. So if you curl it up backwards, place it on the corner and then rub it down, making sure that it's nice and square with the level with the board, then it shouldn't move when you're doing your drawing. You need to have these in place before you start. Next thing we're doing is we're going to first of all go through, we're drawing the Chook feeder as orthogonal. That means a straight bird's eye view from each angle of the actual product. You're going to do your drawings in pencil. We'll come back, allow room later on for us to do the proper border that we have to have on. We can catch up with that later. I want you to get your technical drawings, how they need to be. I'm going to go over mine with a pen so that when you do it, you can see it better for this video clip. I find the easiest thing to do first of all is to work my way either from the bottom or the top up. I'm actually going to go from the top, from the bird's eye view looking in. I'll actually put some pictures and put these together in a series of pictures as well with the actual object photos alongside them. Now I'm just going to turn this off. I don't think we need that light today. I think there's enough light without it. Okay, there's enough light without that light, so that's probably distracting, so we'll keep that one away. Okay, when we're coming back to this, we're first of all going to start drawing in the bird's eye view looking down. So we're doing it a 1 to 4 scale, so we need to make sure we have the scale 1 to 4, which means we're really drawing at a quarter of the size it is. So 1 centimetre will be 4 times equal 4 centimetres. Which means when we're going to do this drawing, we're going to mark in the correct sizes. I will use a pink marker to show the size you have to draw it to keep to scale. So I'm coming down, my ruler slides up and down, always checking that edge is in. I'm going to come across and I'm going to draw a 120 centimetre line, which is equivalent to the 120. So I'm drawing 120, it's equivalent to 480 in the actual object. And I'm coming down to do the next line. So the next line is 40 centimetres down. So I'm using my square, I'm lining up this, so it's not the bottom of my ruler, I'm lining up that until it's in place. Then I'm coming across and I'm lining it up here. So I'm getting my measurements correct. I'm also marking the size. When I mark the size, I just do a little extension out from there, the extension out from the top. I can then draw a line in, and we do our arrows when it's a bigger space from the inside, and this is 160. As I said, I'm going to also you will not do this in 40. This is just so you remember that that is 40 millimetres that you're doing that measurement in. Okay, so that's for you. The black is what you would normally have on your drawing. Up here we need to also make sure we're showing the length so that somebody can make this product to scale. So we again draw our markers up for our size that go in line with the lines we just drew. We draw our lines down for our arrow, which is our arrow is then letting us know we can put 480 millimetres. Why do we work in millimetres? Because engineering drawings are accurate, and that is 120 millimetres. Remember, I'm doing that pink for you, no one else. Okay, that is our top view. We can even label it top view as we go, so we don't forget which one we actually have done. Normally when I'm doing this, I actually have found it's easier if I come back with a pencil and just do a few dots down from that line, so I know that all my lines that are going to be in line are going to show up, and I'm keeping them, and they're called crating lines. We're then going to draw in the top when we're looking at the front view. So we've got the top of the front view. So this line lines up with that. If they were folding, that would be joining together. This box is 180, which means it comes up at 45. So if you watch here, I have to carefully bring my T-square and my set square up so that the marking is exactly on the 45, and then I come down to the mark on my ruler, not the T-square, right on my ruler, so it's coming directly out from that line. All I have to do then is just slide that across. I don't have to do any more measurements because I know that that's correct. I do have to draw the fold in, so that is going to be 2 centimeters, but it's normally, when we divide that by 4, that means that will be 5 millimeters will come out from the 20. So I can then draw it in because I've got my ruler mark here. I can just come across my 5 millimeters. And then I know if I bring this ruler across, because it's right angles, that that line will be correct without me having to do any extra measuring. That is why your part of your test is getting used to using T-squares and set squares, because this saves time. Okay, then you can slide your ruler up. We've got to show the front of the box where the feeder box is. That comes down 120, but that means it'll come down 3. So I'm going to come across, bring my ruler there, do a little mark, so I know I'm in the right spot. Then I know when I draw that line across, it's going to be in the correct position. So we've now got that one. I'm going to mark that one in from here, so that I've got my, I know that that is going to be my 120 for where the actual feeder part of the box is. Okay, so I'm doing that, and that's 30 millimeters for you today. So we're just doing 30 on here for that line. Okay, if we don't put millimeters, people reading the drawing normally would expect it would normally expect a drawing of this type to be in millimeters. So the assumption is that your drawing is in millimeters if it's an engineering drawing. So you don't have to always write down millimeters. So if I write down 180, that will help me know, and as I'm doing the 45 for you, so you remember that what size you are doing to keep it in scale. Again, here I need more information. I need to put front view, so I'm remembering that I'm being really clear about which one it is. I also have decided to put the fold-in section over here. And this one I'm marking a little bit differently because this will be more in line with the next drawing, which also has the fold in. And I'm doing the arrows from the outside this time coming in, because those arrows coming from the outside that line represent the fact that it is 20 millimeters and it's too small a space to write the arrows, which we've actually done it as 5. So I'm just going to mark that off so you know it's 5. And again, I often find just doing a few little crating lines or dots coming down from those, which are considered acceptable when you're doing some technical drawings, just to help people keep their mind lined up. The front view then lines up with the bottom view that also has these folded in panels. So again, it's really easy now because I've got my measurements. I don't have to keep measuring. I know if I come down here and my ruler's telling me how long it is, I've got that measurement that's 480 or 120 in our scale. Okay, so that's there, that's easy. I also know if I line up my ruler here, this one comes down 160, which means it'll be 40 for this drawing. So I know if I draw that line there, I'm correct. I can actually just slide it across, line it up from the one above, because I know that that is 5 millimeters, because I've already measured it once. I don't have to keep re-measuring. That's why we're doing technical drawing, because I can then slide that across, and can you see how much faster and accurate it is when we're using the T-squares and the drawing boards. And this time I just need to draw that line across the bottom, because when I look up at the base, that's what I'm going to see. So it's much the same size as the top view. So again, we need to mark in. We don't always have to mark these in, but it's a good idea to mark in the actual measurements, because occasionally something might be a little bit not be completely square. So if you don't have a measurement in there, you'll assume that it's completely square. That would be the assumption of the person reading it. Okay, and then we've got the 20 there, which then lines up with the bottom there. So this is again the bottom view. So we need to make sure we're showing that. Then we just really need to draw the side. We probably only need to draw one side, but for you to make sure you're remembering and practicing, both sides are a good thing to have, because occasionally you might have something different on one side from the other. Again, often when I'm doing this, I might put a few crating dots out. So I'm just going to start with my bottom, because the bottom's going to definitely be in line with that. The bottom of our side is going to be 160, so I've got a mark on this T-square, so I can just line it up with the bottom here, come across my 40, which is the equivalent, and I can do that really easy out this way, come across and draw that at exactly the same time my line that's 40. Then all I need to do is slide this down. I know I'm doing the next 145, equivalent to 180, so I just have to bring my ruler up in line. I don't have to do lots of measuring, so I've done one measurement, and I'm using the lines I've already got to help me having to do that, so I don't have to do nearly as much work to get all these details in. If I did, I may choose not to draw both sides if I was doing it without a T-square, because it would take a lot longer to draw each of these marks in. Then I come up, the side is fairly simple. Okay, we're going to draw that across. Okay, we don't even need to worry too much about the size, because we know, according to this one, 180, it goes across. If we want to mark that, we can. It's not as essential. So I might go, okay, that one's got that with the 180. I might just do it out this side so that it's a little bit clearer when I'm looking at this drawing. So remember, all your drawings are done in pencil, so you can keep your lines together. What I do know that isn't so clear on this bit, but it will be the same because they're both the base. This joins that section. I will also make sure I'm showing this mark here so that it can't get confused with anything else. So again, the arrows are on the inside when I have room. Okay, I'm just going to put 45 there. I'm going to put 40 there just to help remind you of your sizes. And all I need to do now is I can call this the north side. It doesn't really matter. I just want to make sure, differentiate it from the other. And I can call that the south side. So it's often good to just differentiate which side you're drawing from, so you know one from the other. That will give you your orthogonal. You need to put your name, or the name of your name actually on your drawing as the designer. Make sure you've got scale. It is an orthogonal. So it's an orthogonal drawing, and what it is the Chook feeder base. So it's not the whole drawing, it is just the orthogonal of the Chook feeder base. We have extra boxes in case we need more information. That's all we need to get done for the moment, and I'll try and get another one of these up and going for you. Thank you.